Welcome to class. Hi, in this video we're going to do some physics. We're going to talk about velocity and the sign on your velocity, having positive or negative velocity, and what that does to your position over time. We're going to animate a ball and make it bounce around the screen. And we'll keep things pretty simple, and you can change things and make them a little more interesting to suit your own tastes after you finish this basic one. Okay, up top, you see that I'm declaring a couple of integers, position x and position y. I'm going to have to keep track of the position of the ball in terms of its coordinates, its x and y coordinates. And I'm initializing the ball to be just somewhere near the middle of the screen, doesn't really matter where. And I'm going to increment first the x and then eventually also the y values for the position. Notice that in the ellipse function, I'm actually drawing the ellipse at position x and position y. I'm not putting numbers in, I'm using the variables. And that's important because if you don't use the variables, you can't change the values later in the program. All right, there's our ellipse. It's there in the middle of the screen, looks good. Now let's see if we can get it moving. And here you can see me assigning the value of position x. It's the old value plus 1. So every frame, position x has increased by 1. And there it goes. It's gone. Should we wait for it to come back? In fact, does it exist? What's happened to it? Let's print out position x, and let's just see what processing actually does to keep track of these numbers and see if the ball stops existing once it goes off the screen. Take a look down at the bottom, that bottom window. You'll see some numbers scrolling past. That's the value for position x as it's increasing. Notice that it's still going after the ball is off the screen. Processing is only keeping track of that number, and then it's drawing the ellipse wherever that number is, but it's not going to show up off the canvas on your monitor somewhere. Now what we can do is we can turn this into Pac-Man, right? We can make it so that if it goes off the screen on one side, whoops, there it is, it appeared on the other side. Okay, and so what I'm going to do first is just do what's called a periodic boundary condition. Periodic means repeating. And now, there it goes. We see the ball blink. It appears on the other side of the screen. Now remember, processing keeps track of the value. So if you notice it just disappearing when it's about halfway off the screen and then reappearing halfway on the screen, that doesn't look very smooth. What we can do is we can let processing keep track of the value after it's disappeared off the screen, so it's gone, it's still there, right? But it's going to animate it all the way off the screen. And that looks a little better. Cool. And we can even make it so instead of just popping up halfway on the screen already, it pops up before it reaches the screen, and then has a much more smooth looking scroll in. Great. Enter stage left. Right? Left. All right, now, if we want to be able to change the velocity, anything you want to be able to change, you want to keep track of as a variable. And so the velocity in the x, we have to keep track of as a variable. I'm just assigning velocity x a value of 1. So it should go 1 frame per second. I'm sorry, one pixel per frame. Same as before. And everything is exactly the same, except now we have the ability to change its value. And what I'm doing here is instead of having that periodic boundary condition where it goes whoop, blip, whoop, blip, and just, appears on the other side like in, an old Pac-Man game or something like that. Now what I'm going to do is I'm going to say, all right, the value for velocity is whatever the old value was times -1. So if the value was 1 before, now it's -1. If the value was -1 before, well, -1 times -1 is +1. So multiplying it by -1 is always going to reverse the sign. Okay, so if you have a positive velocity, now you have a negative. If you had a negative, now you have a positive. And this is a useful trick that you'll want to keep track of. Okay, and there it goes. It doesn't look great though, right? It looks like the ball has gone off the screen and then it's bounced after it has left the screen. What we can do is we can go into that if statement and we can just change those numbers around to make it look how we want it to look. Remember that everything that appears on a computer screen, it's not really there, right? There is no ball on the computer screen. There's some colored pixels on your screen, right? Video games and movies, whatever, like there's nothing real there. It's just colored pixels. And we can steer these around to make it look like there's something physical happening. And so what we'll do is we'll just change the value there that it's looking for once we do that. Now, what I've done here, check out those 2 vertical lines. Those are the ones there on my keyboard. They're the ones over the Enter key. I have to hit Shift and then \. That is called a logical operator, and it means OR. Before, what we saw was in a previous video, you saw me type in 2 AND signs, and that meant AND. This means OR. So that line, it says if position X greater than width plus 25 or minus 25, I can't see that small. And then but then it says or position X less than 0. If either of those conditions is met, then processing will execute the code inside of that if statement's block of code. So if either of those conditions are met, velocity X is negative velocity X. And that's cool. That lets it keep track of, one side, the other side, one side, the other side, with just one line of code. Otherwise, we would have had to have put 2 whole if statements in there and rewritten velocity X as negative velocity X. Okay, now what I've done is I've added a velocity Y. So up top you can see velocity Y is an integer. I've given it an initial value of 1. And I'm going to do the exact same thing for velocity Y that I did for velocity X. Except it wouldn't make sense to keep track of velocity Y in terms of the width of the canvas. Right? And so what I'm going to do is I'm going to keep track of the height of the canvas. And take a close look at what I'm typing in for position Y greater than height minus 25. This is going to make the animation look a little bouncier, right? And I'm doing the same thing after that OR statement, or the OR operator, sorry. Okay, so we have a lot of new stuff going on in this video, and it's going to allow you to have some really interesting animations in just a few lines of code here. Okay, let's see the bounce. And yep, there it goes. Great. Right on the edge. Oh, except it's still going off on the right. We should fix that. Your homework for this lesson is to take this code that'll be up on GitHub for you, and I want you to make something else happen whenever the ball hits one of the edges of the screen. It could be maybe the background, maybe something else pops up, maybe the ball changes color, the ball could change size. Any number of things could happen. And it could be an interesting project. If you're up for a real challenge, you could try to make it so that the ball's speed changes every time it bounces off the wall. That'll be the challenge assignment for this lesson. All right, so you just have to change something every time the ball bounces. Good luck with your homework, and I hope it's a fun one.